Okay, folks, we are live this morning, and if you guys are expecting Franklin Hugh or who, Franklin who, I am obviously not Franklin. I am David D. Hilster. I am one of the directors of the CMPS, and this is our Saturday morning chat that we do every week. So I want to welcome everybody from the two channels that we're broadcasting live simultaneously to right now, which is the CMPS channel. I know we have over 500 subscribers now on that channel. And I want to also welcome my subscribers from Dissident Science. I know, folks, I am owing you a video. I have a video actually on the flat Earth movement and why that is getting in the way and being used and being weaponized against us in science, trying to do science progress. And I have it all written out. My script is written, but as you can see behind me, I am no longer in my wonderful studio in my now former house, which has been sold. I live here in Boca Raton. I'm in my father's apartment. He's got a couple bedrooms. So he's been very kind to lend our family a bedroom while we are in the process of buying a home. In fact, we're looking at homes this weekend. So I apologize to all my dissident subscribers out there who have been waiting patiently for the next video that will be coming out. But as you can see, this isn't exactly the most wonderful background. I do have a green screen, but setting that up and all that is not easy. But again, I want to welcome everybody and those people who don't know about some of this. Let me talk to you a little bit. Here, right below, right there, you can see what this Saturday morning chat is all about. Actually, they've been around now for 12 years, this, believe it or not, the video conferencing. It has evolved, of course, but it started in 2008. Actually, I started that as one of the, at that time, I was more like sort of like the internet director for the, at that time, the MPA. And the MPA was founded in the early 1990s by John Chappell. And in 2015, there was some problem that we had with some of the directors who unfortunately wanted to try to take over the organization, and we all left. So that organization sort of has been abandoned, well, is abandoned and is no longer running. But all of the members, 98% of them, moved to what we call the John Chappell Natural Philosophy Society. I'll put that up there. That's our official name. You can see right there in the corner here. This is our logo, which is, of course, the phi symbol from Greek, which happens to be, interestingly enough, if you don't know about that, the phi symbol is actually a symbol for the word for philosophy and natural philosophy. They both start with the same symbol, so I thought that was a really nice logo for us to adopt. Sort of looks like a tree there, doesn't it, with apple falling down, gravity. So obviously a big important part of our work trying to figure out what heck gravity is. But that's John Chappell Natural Philosophy Society. We have well over 300 active members worldwide. They pay dues. It's $35 if you're a senior. A lot of seniors, of course, because people who are retired don't have any financial or philosophical commitments, so they're much more easily to be dissidents because their job doesn't depend on it. And then also we have for those people who are uh, under 65, it's $50 a month. Now, what does that pay for? Well, that keeps our websites going. Two very important websites that we have, and actually more than that. We have naturalphilosophy.org, which is our website, which I've actually started to rebuild. One of the millions of things. But, so I've started getting us a newer version of that website. But it is there. You can register and become a member, and it does help us support our work. We also have the website, really, that we send people to if they are interested in becoming more of a dissident, is sciencewoke.org. It's doing quite well, actually. We have a lot of views a day. I think we're averaging, I can go over here and take a look. But we actually have a page. You can go on sciencewoke.org under About, for those who don't know that, and the page views. And Yeah, we're average about 50 or 60 views a day, which is quite good. And it gives you a really good introduction if you're a layman or you're a real science lover as to what the problems are. It really is a website to get people interested. It's got great articles that we have on that. We have a lot of great writers who write articles for that. And so you want to check that out, sciencewoke.org. It's a really great place for you to start out. And of course, we do have our YouTube channels as well. We have youtube.naturalphilosophy.org, which you are probably watching right now. And we have 13 people watching, so I welcome everybody. And also from youtube.dissident.science, the YouTube channel for Dissident Science for those people who are familiar with me, and we are broadcasting live simultaneously, and that's one of the both of these channels. That is a Natural Philosophy channel, which has, like I said, over 500 subscribers. Let me go and check what the counts are now on these, but I think we're over 500 subscribers for 573. So we keep on growing, which is great. When we started a couple of years ago, I started the idea of making us more visible on the platforms of YouTube and Facebook, etc. We only had 120, and it was pretty much stuck. So we are growing. Dissident Science, that's my channel that I have. Again, I welcome you subscribers. Approaching 3,000, and that's really great. And we have other channels like Jeff Yee has his channel, Energy Wave Theory, and that channel is, of course, about his work, and he is one of the CMPS members. He's a young and upcoming scientist. Love his theory, very different from other models and theories. My father and I also have our model and theory, and other people do, of course, in our organization. And our goal with this organization of the CMPS, the John Chappell Natural Philosophy Society, is very unique in that we are a society that actually not only tolerates multiple models for the universe, meaning people are free to come up with new models of the universe, but we actually encourage people who are working on their models, even if we don't necessarily agree with them ourselves. And I think that's one of the biggest problems we have in science today, is that's not allowed. And that's certainly an impediment for science moving forward. But Franklin Yu is on a well-deserved vacation. I'm not sure if it's a vacation from this or if it's a real vacation, but he's up in the not Bay Area. He's up in the the Seattle area in the state of Washington. So we're at absolutely opposite ends. I mean, unless he was in Barrow, Alaska, we really couldn't be further, because I'm here in Boca Raton, Florida, and nice and warm and sunny most of the time. But he had told me that he couldn't do this, and it turns out that in the next 2 Saturdays, myself, I am open, and I'm really looking forward to having also doing this, because again, my subscribers on the Dissident Science channel, YouTube channel, are wondering what the heck happened. Just a little bit of backstory. Of course, if you just joined, especially if you're one of my subscribers, Dissident Science, you can see in the back that is no longer my library where I was in my own my last house. I'm currently looking for one, and I'm right now in a bedroom. That's one of the reasons I haven't made videos. I do have a green screen where I can set it up behind me, and that's what I've been trying to do, getting lighting well. You know, it doesn't look like I have lighting, but I do have lighting here, because it really makes a big difference when you are making recordings. I have the entire thing scripted out for over a month, but to actually record that and edit that usually takes numbers of days. So I apologize about that. But today I thought we would talk about a subject that I think is, I do watch a lot of the recordings of this, so if you do miss this or you can't participate, you can actually watch these recorded. In fact, this one will be recorded in 2 places. It'll be recorded on the CMPS website and YouTube channel, as well as Dissident Science. Getting some of my Dissident Science subscribers may be interested in coming by. And the idea of this whole thing is for us every Saturday morning to be free to talk about concepts that you cannot talk about anywhere else. And to give it a little bit more background again for those people new, the idea is to bring some of you guys to this platform that is a lot of my subscribers in this direction, is really to show you that we are in fact here, and we talk about cosmology, physics, sometimes mathematics, natural philosophy. Philosophy is very important. In fact, the idea of charge being real or not. And what things we do not talk about on this channel or in our organization are religious or political, and sort of off anything that's really off target topic, because we have many persuasions. One of the great things I love about this organization, CMPS, is I have dear friends who have extremely opposite religious and political views. But it doesn't really matter. What matters really is our science. So it's really important for us to accept everybody, no matter where you are on the political spectrum, where you are on a religious spectrum, cultural. We just don't care. In fact, when we have our conference, our annual conference, we have people from around the world at those conferences, and when they stand up and talk to us, these are the things we do not care about. We don't care about what your title is. In fact, our the CMPS's chief scientist is an MIT graduate with a degree in physics, and specifically in special relativity. Her name is Dr. Cynthia Whitney. And so it's not that we don't have people who are have really great degrees in physics or cosmology. We also have retired NASA scientist Dr. Edward Dowdy, who is fluent in German, who also those two, in fact, Edward Dowdy is always disputing general relativity, and of course Dr. Cynthia Whitney has had her thesis on special relativity, tried to apply it to a ring gyroscope, which involves the Sagnac effect, which is actually light going in a circle, and it failed miserably, and that's one of the reasons she got into it. So, our goal is to be here, is to support all these types of discussions. And if you are a person who has new ideas in physics or cosmology, and you want to publish the John Chappell Natural Philosophy Society. In fact, our proceedings are open right now, and that is if you are interested in publishing your paper, even if it's been published somewhere else, we don't care. You can publish it in our proceedings. We do read it over, make sure it's something that is important for us, but important, and we think that is good work, representative good work, and of course then we will in fact once a year publish that in conjunction with our physics conference. Last year was at the University of Washington in Seattle. This year I'm not sure, I've not gotten a place for it. We're thinking about having it here again in Boca Raton at Florida Atlantic University. For those who don't know, there's a campus here in this sleepy retirement town, not too sleepy, but of Florida Atlantic University, which actually has 35,000 students, so it is not a small university. But anyways, I want to go forward and talk about that. I welcome everybody in the chat. I am reading those. And I'm going to go through a few of those before we go, because one of the things I do want to do is make sure people are participating and saying hello. There we go, Sean Becker. Hello, everybody. And Ann Unknown, hey D. Maybe that's for me, David D. Hilster. Oh, there we go. My dad, he and I are writing a book. I'm in his house right now. We are finishing up our book on the particle model. And that's a lot of fun. We hope to have that out this year. And by the way, the particle model does not use charge. There's no charge necessary. And that's one of the things we're going to talk about. Let's look at some other ones. Hey, Dave, sent you a PDF of my book, The Instructional Manual, as written in the Cosmos several months ago. I think I have taken a look at it. I will address that later, not necessarily today, but I will get in contact with you. Those people from my Dissident Science channel that do send me things, I'm very interested in knowing about that. He says, hey Dave, I want to talk to you about some physics issues. That sounds good. I am open to that as well. Again, today we have our science chat, but again, with the modern world here going live, it's very important for us in this venue to interact, because that's the idea. People want to come back and be able to ask questions, take a look at it. And also, one of the things about going through these is people will have suggestions. Well, some of our people in the CMPS may in fact want to take a look at some of these links that people send us. Have you checked out Steampunk Physics YouTube channel? I think I have. There are quite a lot out there, and there are sort of different veins of YouTube channels. I have lots of YouTube channels. I really enjoy myself on physics and cosmology. Some are well done, some are more chat. Some, of course, are a little bit more out there, but of course, that's what's great about the world. Everybody should be able to go out there and say what they want and talk what they want. Another person says, Walter Russell is the physicist to study. Okay, well, that's something we can also take a look at later on. But let's see. First of all, I want to ask, okay, nope, we don't have religious questions here. We're not going to do that. So that's not one of the things that we want to do, because let me give you a reason why before we start a discussion on charge. One of the reasons is that's a very personal thing, but it's also, I think, is something that right now, physics and cosmology are so problematic. We have people in our group, we have argued for a long time, and I do subscribe to these following things. The Big Bang didn't happen. It's an eternal universe. Relativity, both special and general, are wrong. Particle physics and the particle zoo of particles they have, it is a mess. And I believe, like Alexander Unzucker, that we should throw everything out starting about around 1930. I would go a little before 1930 and also throw out the neutrino with that. But I would say also, what else? Oh yes, plate tectonics is not the correct model. Expansion tectonics is a much, much better model. So we have all these problems that we have to deal with. And what we don't want to put on top of that are the problems of talking and bickering between us about, religion or politics. That is for other channels, that is for other places. We want to concentrate on science here. Like I said, I have friends who are very, very different from myself, both politically and religiously, but I have no problem in talking with them about science. So that's one of the things we do want to keep an emphasis for. All right, let's see here. We have some more video, 20 minutes suppressed history. Yeah, there's again, I'll get a couple of these before we get going here. Check Lloyd Pye's video, 20 million years of suppressed history on an alternative creation, evolution, and design. Yep, that's something. Yep, you can check that out if you want, but we're not really going to talk about that. So, anyways, let's talk about it. And I'm going to start out with this idea of charge. And we have some people. We have I see here we have Bob Gray, James Keane, and Mike, XPTech Mike. Oh, he's got thumbs up. We have Stephen Scully, I see, just jumped in here. So if you are interested in actually joining us, we have a waiting room, a worldwide waiting room. That's why this technology is so absolutely fantastic. Again, sponsored by the John Chappell Natural Philosophy Society. If you want to join and help out, the reason this exists is because we pay a subscription to it. We have our websites. All of these things are paid through the dues of our members, and I want to thank all our members. And this allows us, this is called Steam StreamYard, and StreamYard allows us to broadcast actually simultaneously to, in this case, I think we can do two. We do actually have another way to stream actually to four, but I'm thinking this is working out well for us, all through StreamYard really, and allows us in in case to do these two live. So that's really great. And in this technology, what it allows us to do is if you want to join in and talk, is really, really important for you to have headphones. See these big clunking things I have? And actually, they're sort of wearing out here. This is because, of course, this is my mic I use for my broadcast. So yeah, it's a professional mic. Yep. So, but that's not really necessary. We don't care about the microphone. What we do care about is having a headset. And the reason is the moment we turn you on, if you are going through just your computer or even your phone, what will happen is you get a feedback because you have a feedback loop. We're all love science, we know that. Comes out your speaker, goes back into the microphone, and over and over and over. So it's very important for you to have yourself set up well, and if there's a problem, we're not going to put you on because that's really annoying for people. So anyways, thank you all. We have 10 spots, and I can put them all up here, as many as 6 at a time on a line for the actual discussion. But I am going to start it off and with the charge. And the first thing is a couple of things about people who don't know charge, because this is something I was fascinated with for a long time. If anybody maybe in your chat wants to answer this question, who was the first person to actually come up with the positive and negative signs for what we call charge, like putting a positive sign on a proton and a negative sign on an electron? If you do not know that, I'll sort of leave that up and see if anybody can get it. It's not easy to Google either, but probably somebody's Googling it right now to come up with it, but that's okay. But that's something that, where did that start? You'll be very surprised. I think a lot of people are surprised about where that starts. But the idea of charge, of course, is positive and negatives attract. And of course, when you put that notation on something, that is a way to try to describe flows of things, in this case, electricity or electrical flow. And that was... I see no one coming up in the chat with the answer, so I'm going to keep going because I'm going to have to say his name. Benjamin Franklin, the great, how do you say, he was a Renaissance man. He was a person of science, philosophy, politics, a humorist, the whole thing. But that was Benjamin Franklin who first put the plus and minus down. And so we use that notation for attraction, repulsion. So if we put a plus on something and a minus on something, that is a notation that we use that those things will attract. If we put the same signs like positive, positive, negative, negative, then we would, onto whatever it is we are talking about, those things will in fact repel, and that's the convention. And my contention is, and it's actually been pretty much ever since I really started thinking about it, is that that is a convention used, and we have now become so, it is so ingrained that now we have people believing that charge is an innate thing. And the way I would argue against it, and the way I can, and of course you say, Dave, if it's not charged, what's going on? What makes things attract? Well, we have, our particle model does not need charge, and the nucleus and things that go around the nucleus and the nucleus of atoms stay in orbit for different reasons. But anyways, the idea is that if you have charge in your model, it can cause an immense amount of thrashing. In my opinion, it's not only not a physical thing, but it has been keeping us from moving forward with better models. And the reason I say that is because if charge doesn't exist, and that is because we put a negative sign on an electron, and then we make fields, and then we say, does a moving electron cause a field? My question to that, and that's where my father and I are working on our own model, and I'm not here to talk about that at all. But my question, and my question to you guys is, okay, what is a field? What's really going on there? And if you have charge that is a fundamental thing, you have to understand the way I would look at it, or my father would look at it. We would say that's a magical property until you can come up with something. That is, if you have, let's say you have the ultimate particle. Here it is. Here's the ultimate particle. The entire universe is made of that. The only way for an ultimate particle to organize itself is to have attributes that you imbue upon it. One of them may be charge. And those to me are just magical attributes. And I don't like that. And I don't think the public likes it. I think the public has a real problem with everyone talking about charge and fields. And the public's going to come up and say, well, that's really great, Dave, but what is a field? I want to know physically what a field is. Tell me what it is. And Yonel Deneu's underwater experiments gives us a great idea of maybe what magnetic fields are. Don't look, if you don't know about that, look them up. Yonel Deneu, Ionel Deneu, underwater experiments on YouTube. So that's my contention, and I'm not alone. And I'm going to open up this, of course, to discussion. We've got people, hopefully, who are interested in talking about this. I am monitoring the chat. Of course, it gets silent when you talk about this because people don't know what to think. It's hard to, to talk about this because it's not an easy subject. But what we want to understand is that you have to know that there are now models coming out. I know at least two of them, if not more, that have no charge and who are philosophically like myself, and actually the three people I know, my father and I, and the particle model, which is a neo-mechanical model based on infinity and Borkert. And Borkert's ether model, neither one of those models believe in charge or use charge and say that attraction is caused by physicality, not by some magical plus or minus sign. And so that's really my point of departure here. I remember Franklin, I jumped in the other day in one of the talks, and he says, of course, charge is real. We all know that. And I think, do we? And the question is Occam's razor. If you have a model that does not need charge, then you have to then do some explaining why a more complicated model with charge will work. So I have down in our room here Bob Gray, James Keene, Mike, XP Tech Mike, Stephen Scully, and Alistair Laptop. Please let me know, wave your hands or something if you're interested and want to talk. Oh, yep, I do see this. Let's see. This is Mike. Are you there?
Yeah, I'm here.
Hey,
yes,
good,
I'm
Mike.
here. But,
oh, good.
Yeah, I'd love to talk, but I'm listening first.
Oh, okay. That's no problem, but it's really great to have you on. Where are you located in the world?
I am in Mountain Home, Arkansas.
Oh, Arkansas. All right. Yes. My sister used to live in Arkansas, but I have not been there. So you are a person that's observer today. Are you a person interested in dissonant science? Before we go on and talk about the subject, maybe give us a little bit about your background. What makes this interesting to you?
Well, I agree with you regarding the special relativity. Pangea theory, the subduction, all that stuff is ridiculous. Also, I believe there's a point of all astronomical bodies grow. Everyone,
right,
the sun is growing. Everything is growing.
Oh, did you hear today? Did you hear that just came out that NASA, or not NASA, but JPL just announced that they have measurements and say that Pluto is expanding. It just came out. Did you hear that?
No, I haven't heard that, but that's,
in fact,
it's a start.
Yeah, I'll look it up while we talk. But so that, are you just interested in the expansion tectonics? So you know some of the people that area. How did you get into that?
I've listened and observed people talking about it, and then did a little bit of research myself. That's about it.
Is that something just an interest of yours in general, or just physics all around?
Oh, physics all around, of course.
Okay.
But it's got to make sense. I mean, there are so many red flags and loopholes that don't make sense. String theory is.
Oh man, that is the epitome Well, you know what's funny? Just to let you know, Mike, back in the 1990s when I lived in LA, I did read an article and I've tried to find it I tried to find it, but it actually was an interview during Caltech's. They have these science days, which Caltech opens to the public. And the idea is for the public to come in and these grand people who in physics are going to come in and talk about, try to explain unexplainable, theories. But anyways, one of the interviews was with one or two of the original string theorists. And one of the things I remember, I was hit over, and I wasn't surprised. I was surprised that they said it. They asked, well, what do you think about this science? He says, look, what I can't believe is that the idea of string theory was a mathematical exercise. It was never intended to be anything but that. It was never intended to be ever looked at as a real model. And yet today we have people getting PhDs all around the world. And one of those original guys literally said in the article, I think it was in the LA Times or in one of the newspapers at the time, they literally said, I am so depressed about why, seeing that people actually treat this stuff for real. And you see it on TV, you see it on the Discovery Channel, you see people coming up with these amazing graphics, right? I mean, if you see these amazing graphics, the graphics people are building these things and all that, and it looks great. But the whole thing is is a joke, and no one seems to care about that part of it. So
it's where people are believing that credentials and authority makes truth instead of truth makes credential and authority.
Right. Well, one of the reasons I like our group so much is that literally when people stand up in front of in our conference, they get up to that podium. We don't care at all who they are. We don't care. We have people up there with PhDs from MIT. Numerous of our members have that. Other people, one guy is an ex-Supreme Court justice from Canada. And when he gets up there and talks, we don't care about that. And we have other people who don't have any science degree at all. What we care about is something that I say in my movie, EinsteinWrong.com. And the reason I bring that up, Einstein Wrong, The Miracle Year, you go to EinsteinWrong.com if you want to take a look at it. It took me 7 years to come up with the theme of what I call the CMPS's sort of mission. It says, or phrase, don't listen to me, listen to what I say.
Right, exactly.
And so what that means is don't listen to me, meaning I have a title or something like that. But anyways, Mike, it was great chatting with you. I'm going to put you back down, and thanks for your support. And if you have some ideas and ever want to write them down, we have our proceedings, and we also have our conference. And I know, and man, 2017 in the University of Vancouver and in actually Canada, we had James Maxlow, who is the guy in expansion tectonics. So going to our conferences, normally we try to have somebody really great there. So
yeah.
All right. I'm going to take you down. Thanks so much, Mike. Great chatting with you. All right, so we have some more people in our waiting room. I was wondering, anybody wants to talk about charge? Oh, no one cares. I'm bringing up this, and we can talk about something else, but anybody want to defend why charge is an inherent property? I don't see anybody. James Keene, you don't have any opinion about that? Or how about you, Steve Scully? Are you interested in speaking? I didn't bring you up yet. I'm going to bring you up. Okay, hey, Steve, how you doing?
What's up, everyone? Thanks for having me on.
Hey.
Let me fix my mic.
Oh, no problem. You are, oh my gosh, look, are you like somebody, like a YouTuber or something?
Yeah, well, I stream. I do everything I can to try to get my message out there of my research.
Oh, okay.
So I do Twitch streaming. I do YouTube videos.
Oh my gosh.
I'm all over the place trying to get my research out.
And what's your research about?
Actually, well, it's about physics and natural philosophy. It's based in natural philosophy.
Oh, okay.
It's consciousness, because it basically relates the functions of physics to the functions of consciousness. For example, two magnetic fields. If say I look at something in one way, and say someone says general relativity is true, we're in opposition. If we get close to each other, we're going to have basically a repulsion. due to our looking at things in different ways. But if we look at things in the same way and we get close to each other, there's going to be an attraction. And that is like a example of the physics of consciousness being a parallel between the two. But as far as charge, my model, the way I interpret it is it's an infinite nature. The ether exists, but the ether isn't just small particles. Everything is the same. And
so do you know Borchert's work? He pioneered sort of that. It's an infinite theory, which means ether happens at all levels.
I've looked at it.
Yeah.
I don't agree about some things. I can't remember exactly.
No, that's okay. Yeah,
there's a lot of things.
Yeah, that's
obviously it's nuanced.
Right. But yeah, the infinite part of it, yeah. And
Yeah.
the thing is about one of the things is that in when people talk about these fields or magnetic fields and repulsion and attraction, one of the things in I'm not here again to push our model or to talk about it, but it's the one we do worry about that and what an actual magnetic field is, which is a flow of particles and circular flow of particles. Now, when you have those, depending on what model is, would be able to support an idea like that or not. So that would be something, again, it all goes back to me is like, okay, we talk about the magnetic fields, but how are those actually constructed?
Yeah, so in my model, it's a figure 8 caused by gravity of the ethereal particles that actually pass through the system. And so when they pass the center of gravity, they're caused to bend back into a figure 8, basically, which then arises in particles.
So when you have those flows and those magnetic fields, what makes one attract and what repulse?
Well, it's not an actual attraction or repulsion. It's basically pressure. So there's a lot. Then it's gravity. So what's gravity? So I'm saying that there's a figure 8 caused by gravity of the Earth. So let's say there's particles pulled by the gravity of Earth, pulled even though it's not actually pulled by the gravity of Earth into a figure 8 orbital due to their proximity, and then that leads to a figure 8. But then there's also different things, like it has to be rotating. If it's not rotating, then there's different balances in the gravity, which then leads to a weaker magnetic field. So like Venus doesn't rotate very fast, and that actually leads to it not having a magnetic field. We kind of think of magnetic fields as being related to some flow of charged particles in the Earth, which is, as you know, nonsense.
Okay, so do you believe charge is real or not?
No.
Okay.
Well, it's emergent. I mean, it's something we observe, but it's due to pressure, basically. So in the ether.
Well, I think it's
interpret it.
Yeah, I understand. I think the way I would look at it, it's more of a convention to me than comes out in an observation.
But it's something that we can observe as emergent, basically. So the way I say it is, say a particle any particle is going to have a radiation out, so like a mass out, and then it's going to have a environmental pressure of the ether on it, a mass in. And so if the mass in is greater than the mass out, then basically the particle is a low pressure particle, which makes it observed as a negative charge.
Now I have a question for you. What is gravity in your model? What's that? What
so it's very much like Lesage, if you know Lesage gravity.
Lesage, yeah.
Lesage, where essentially it's caused by the ether and then by blockage of the flow of the ether.
So you have a flowing ether model, is what you're saying?
Yes, okay. Because essentially it's the smaller the particles are, the faster they move, approaching an infinite velocity to the point where we then see it as acting instantaneously, which is why gravity is instantaneous.
So do you believe in instant, like you had mentioned that something, I don't know if you said charge, or magnetic field that goes out infinitely? Is that what you're saying in your model?
I mean, to a degree, there's
okay.
The universe is infinite. It's just I'm not sure.
So do you subscribe? Well, no, this is interesting because the most important to us is to, our organization is out there to, support everybody who's working on new theories. Because the way I look at it is this: everyone should be able to. I mean, the human race. I mean, there's nobody who can contain our mind or our ideas. We are allowed to come up with what we want, as long as I am not coming over and cutting your head off or causing you any real physical problems. We have the right as human beings to think and come up with any model we want. The problem was we do not teach that. We do not teach people that. We do not allow them to. And with that, I think one of the problems is also it's really hard for anybody who has a model like yourself. My father and I have a model. Bill Lucas, who's in the waiting room, he has his model of the universe. Glenn Borkert has his. Jeff Yee has his. The problem a lot of times amongst ourselves is to try to argue, what is right or wrong, instead of discussing terms of trying to understand it. I mean, I can sit here and try to pick apart your work or try to understand it. And I think one of the things is I try to make people in our group try to understand is that let's try to understand the other guy's model, even if we don't agree with it. Because if we don't do that, who else are they going to get support from? And of course, a lot of ideas on people who have models are out there saying, this is the right model, and my goal is to let everybody know, whether you're a dissident or not, you're wrong, I'm right. And I think what we have to do is step back a little bit and say, okay, this is a democratic process, and that is, if your model's really good, and it makes sense and people like it, they're going to start using it. They're going to start writing about it. Those things will happen. So our goal, and what we need to do, though, to even get there, is to do what you're doing. Tell us a little bit about your channel. You have a channel out there. How are you, and how long you been? Do you have a YouTube channel, and how many subscribers do you have?
I have like 100 subscribers. I'm
okay, so you're just starting.
I'm not starting. I started 5 years ago.
Okay. Okay.
But,
okay.
I quit my job as a patent examiner. So to
Right.
get a little background, I'm a chemical engineer.
Okay.
I quit my job as a patent examiner, which I did for 7 years in fuel cells and batteries, when I basically my thoughts were focused on all distant redshifted galaxies. And I felt that because they were interpreting motion to be the cause, that they were essentially leading to all these illogical conclusions. And so my thought was, well, what about gravity? And the thing is, if the way gravitational redshift works, I thought, well, maybe there's a larger object. So not just like there's planets, there's stars, there's black holes. Maybe there's something that galaxies orbit, like an even larger object.
Right.
And even larger. And somewhere down the line, that object is gravitationally redshifting everything, causing all distant galaxies. And how would it do that? That's the question. Because if it's in one position and in the sky, the opposite direction, we're going to see a blue shift because the light's going to be going towards that object. And so we would have this dichotomy. And so I just was like, well, this makes more sense, but I don't see how it could possibly produce the observations.
Right.
But then one day I actually had the thought, well, what if it's also bending the light? And that's when I quit my job, because I knew that was actually so much more logical. But
so can you support yourself? How do you support yourself?
Well, I did. Well, I mean, I had money. Now I'm living with my parents. I'm working.
I got you. But you know what you should do? What I would recommend you, actually, a book I would recommend, because on the cover talks about, I have a picture of exactly what you talked about. And that is The Universal Cycle Theory by Stephen Puetz and Glenn Borkert. On that cover is a structure to which they say that a lot of the stuff in our universe are orbiting about So
Yeah.
I think that's really interesting to look at. Okay, I'm going to keep moving on here, but listen. First of all, Steve Scully, you should try maybe hook up with us a little bit. Maybe we can get more people
Yeah.
interested in what you're talking about. I think you have a lot of things that are actually quite good concepts.
And I have a lot to say.
Yeah,
I could go
yeah.
on for weeks,
Right. And then
honestly.
what we need to do is make what you need to do is start getting your work out there a little bit more formally. I think that will help. And we have an organization that can do that. And one of the reasons
No,
I'm bringing you up here and talking with you all about this is to give people who are current, who have their own work, that this organization is for those kinds of people, and to even, present their work. Even on the Saturday morning, we do have slots open. So if you want to in the future do a presentation, anybody else here, we're going to get back to charge, of course.
definitely.
If you want to come on and you would talk to Franklin, who's usually in charge of this, and you would get an hour to present, usually with slides is very good to have a little bit more organized. And then from there, you would then go ahead and have an hour after that where people would ask questions, challenge, and all that kind of stuff. So it'd be something. But listen, it was really great to meet you, Steve.
Appreciate it.
All right, and we're going to keep moving on here. And my father's like, well, I don't know. My father, Robert D. Hilster, says, I want to talk about charge, and he actually brought up a very good point, and that is, he said, let's see here. If no one else wants to talk about charge, I will. Battery versus magnet. Now, one of the interesting things with the particle model that we're working on is that you can, when you get a magnet and you put a magnet down on your table, and then you get little compasses. My father bought a bunch of little compasses. You can place those compasses and get an idea of the shape of the magnetic field. There's actually some other people that do that. I don't know if Distinti is one of those people. There's a guy out there who has this total new, I can't remember. I'm sure somebody in the group will be able to tell me. But he has his way of looking at and detecting those fields. But it's very interesting that my father's bringing up is that when you put a battery on the table, you can also see a magnetic field. And one of the things about our particle model says that all the energy stored in a battery is not only chemical, but it's also in the form of what people call a magnetic field, which we say are particles whirling around. But that's quite interesting. So, all right, we have some more people here. I see. Bob Gray is there. So if somebody wants to talk, Alistair Top, I don't see everybody who has a video, so it's hard for me to see anybody's hand raising. But if you are interested in the discussion, of course, is today about charge. My contention is it's a great, I'm not even sure that's true either. I'm not sure it's a great model or a great system. I would call it more of a system. But if you're interested in discussing that, you're certainly well to come on and give your. I got to get my dad to get his video working on this. But anyway, James Keene, Michael, I see there's Michael there. He's got headphones on. Would you like to speak on the charge, Michael? I see you there. I'm going to bring you up. Okay. All right. Can you hear me?
Can you hear me?
Yes, I can.
Can you hear me? Yes.
Yes.
Well, I'm interested in the subject, but I'm more interested in the process and this metaphysics, whereas models, of course, are always Boolean. And this word dissident, I'm not too happy about. It seems too self-deprecating. Science advances by people mainly known through time. And mainstream is always about 100 years out of date. It has to be, because it's just natural evolution and growth of knowledge. And so the work that I see or hear done on your channels, I wouldn't call it dissident.
No, it's not really. Yeah.
You can't use the word right or wrong.
Yes.
You see, that's all Boolean. I mean, Einstein is quite a good model, but it's a first order model. because it's based on number, whereas you need to base it on process. This was pointed out by Alfred North Whitehead. He, with Bertrand Russell, founded set theory, and it's the basis of modern set theory. But he and Russell denounced it or renounced it, and from the 20s got into process and metaphysics. The difference between metaphysics, of course, is that it's down, top down, not bottom up. Mm-hmm. So in process, for example, the ether is not physical, it's metaphysical, it's logic. So it's logic which controls it all. And really you need later mathematics of category theory and the sense of adjointness to give it to the logic. And it's not a Boolean logic, it's a Heiting logic, which is a multi-value, 3-level thing. And therefore, the adjointness doesn't give you positive and negative in the sense of plus minus. There's no such thing as negative, actually. Negation doesn't exist. It's just a special case of the open operator, because it always implies a closed world assumption. And so really you're feeding in from the start some assumption. And so what you get out is the results often of the assumptions. I mean, Hawking's is a very good example of that. His thesis, PhD thesis, which is now online, and you can see that on page 3, he actually assumes the existence of zero. Well, the zero doesn't exist anywhere in the universe, and also infinity, and infinity doesn't exist. So it's not surprising he ends up with Big Bang and black holes. I mean, he's assumed them at the beginning, you see. That's particularly about the zero is important, because, as I just said, zero doesn't exist in physics. Now it's a mathematical concept,
yes,
as is infinity, and being very powerful, but only in local models.
Yes,
local
yes.
Compared to global, and the world now is globalized.
Yes.
Science has. So in postmodern science, which I think Whitehead really was the leader in that field, showed that really the approach is wrong to talk about models, and if you're going beyond first order.
Sure, and I think let me make some comments. First of all, number one, you bring up a super important point, which is the idea of natural philosophy. What people in the world, when we came to the 20th century, we had a great shift in what we call science, and that went from natural philosophy to what we then called physics. And one of the things that you also said that was extremely, and that's really important, people don't understand, and people in this group do, especially the people who've been around in this group for a couple of decades. We have some really great philosophers. One is, what's his name? Peter Marquardt, Dr. Peter Marquardt from Germany. He is a really great, he's a philosopher. Also, Glenn Borchert is a philosopher in our group. Now, what's also interesting is the idea of mathematics. There's a number of things you talked about. Mathematics, we have a person who spoke at our conference a couple years ago. And one of the things is my father just wrote a paper on, is that there are no negatives in physics. There are none. There's no negatives, like you said. It just doesn't exist in the physical world. As we have a mathematical system, people don't understand that the real number system with the square root of -1, for instance, is a problem. It's a problem not of the universe. It's not that the universe has a square root of -1 or an I in it in the equations for electronics. The problem is it's our system that is a problem. And also you had talked about, zero, infinity. And the other thing is, I would say, is that the way I look at models, I think it fits what you're saying. And that is, the best we can do is cobble together some idea, some model, some physical thing that we think is happening in the world, it's never going to be it. But we look at it in a local area and we try our best. Your model may be a little bit better at predicting stuff than my model, but the idea that that is actually, the universe or actually the way everything really works, that's a different story. And I absolutely agree with you. People have this tendency to get so caught up in the math that you have people like Sabine Hoffenfelder, who worked at the Large Hadron Collider, who left it in the middle of the super collider and comes out and writes the book called Lost in Math. And I think that's one of the things. I think what you bring, Michael, is a very important point, that philosophy, natural philosophy, and that's why this is called the Natural Philosophy Society, is really, really important. And people don't understand that. They get caught up with charges and moving electrons and fields, and we don't understand that there's a whole philosophy about the way science works. Well, thank you very much, Michael, for those comments. I thought they were really great. And where are you located in the world?
In England.
In England,
I'm
okay.
in England.
Okay,
Devon,
and
in Devon, yes.
do you have
It's
any?
late afternoon for me now.
Right. Do you have any work that you have on the internet, or anything that you that people could, or are you just?
Well, I've written about 400 papers.
Wow. And where can people find those?
Well, many of them I wrote with a collaborator called Nick Rossiter, and he keeps a website. Don't bother. I haven't got a list of my publications. I'm not even sure how many exactly there are, but he has many of them, probably 200 or 300 of them.
Okay. Can you?
If you go to his website, Nick Rossiter.
Okay, so can you type that in? Can you type that in the chat for everyone?
I don't know. I don't know how to
okay.
type this.
Okay, that's no problem. Go ahead. I'll type it in. What is it now?
It's just
spell it for us.
Nick. Nick Rossiter. Rossiter.
Okay, I put that in
members of the Alternative Natural Philosophy Association, which has been going on in Cambridge for about 30 years.
Wow. Wow. See, organize. Well, that is absolutely super. If you ever want to present any of that kind of work to the group, that would be also interesting. Or if he wanted to, or somebody in your group would like to, we have a worldwide audience who's open to these kinds of subjects. Absolutely. Yes. I think it's fascinating.
I'm a long way away, though, and a long distance away, because the universe is a topos, not Euclidean. Mm-hmm. And that makes a big difference. It's due to the connectivity. Mm-hmm. And you get this where the exponential comes from. Everything's, well, no, Whitehead didn't use the word connected, he used the word non-separable. Mm-hmm. It really means everything is potentially connectable. Mm-hmm. And particularly a jointness is the natural language of the topos. And this is where the opposite is different. This is the Heiting logic. Whitehead goes into quite a bit on this. For example, Newton's first law, an entity continues in a straight line until, he says, well, what's a straight line? You might say, well, it's the shortest distance between 2 points. How do you know? Right. How do you measure it? Well, you use a ruler, of course.
Yeah.
And then the second law, likewise, he says, the second law is just force time acceleration equals force times acceleration. The third law he didn't get to because he died in 1947. But the third law can now, that's where you need category theory to show that the equal and opposite are separate equal. The equal bit's okay. Although he said again, there's no such thing as equal. If you have 2 times 3 equals 6, well, obviously they're not the same, are they, both sides? And there are no 2 things the same in the universe. So
Sure.
this is where he talks about becoming. So 2 times 3 becomes 6. So the equal sign really is misleading.
Yeah,
Because
no,
again, it's got all
absolutely, it
these
is.
overloads of all your assumptions, and it's not a lot of progress if your assumptions just bear out your assumptions at the beginning. So this is the trouble with maths. It's axiomatic. Mathematics is not science.
Yeah,
Physics
no,
is science.
absolutely. Yeah. And unfortunately, you hear a lot about that. One of the interesting things is when you're talking about the mathematics, is not science. That's really hard for some people to understand because some people, I remember talking to somebody and I said, do you think general relativity, and we were talking about general relativity. He goes, oh yeah, that's correct because it's the tensor equation. I said, well, tensor equations are just a mathematical system trying to model something. And it turns out, is that there's no physical reality. And the guy turned to me, and this is a guy who's a bright guy. He's just, no, tensor equations are physical. It's like, people really have a hard time extracting the idea that in the Venn diagram of natural philosophy, that physics, the physical world, and mathematics, there is really no overlap. The only thing that we do is we use math to try to make predictions in our local part of the world. And the other thing too is you said that's very interesting that some of the people who know in our group is Dr. Glenn Borkert, and this is really shocking to some people. It's like he said, there's no 2 things that are equal in the universe. You can't even have 2 what we would call electrons equal. You can't have 2 atoms that are exactly equal. There's no equality, and that's that's a philosophical statement that just is so foreign to people because these things, because like you said, it's a level above a physicality of a model, and some people just don't understand that. Like I don't know if you've ever seen the Veritas model by or mathematical it's written by Peter Erickson. He came up with a Veritas numbering system because he was saying, negative numbers, we have a huge problem in the system we have today. So I think it's very, very interesting for people in our group to be exposed to these kinds of things. So what I'm going to do is we have the information from you, and hopefully maybe we can get.
I don't want to divert you from
No, that's okay.
But my point really is you cannot understand charge without category theory, because first order mathematics cannot deal with it.
Right. That's understood. Thank you so much, Michael.
There's no such thing as particles.
That's
what Whitehead calls concreteness. There's unreasonable assumption of concreteness.
Right. No, understood. Okay, well, thank you so much, Michael. I really appreciate your comments. And again, the sort of impetus of our discussions here is charge. So people want to talk about that. One of the things people do talk a lot about, again, one of the things I've heard talked a lot about on this discussion on Saturday mornings are moving charges in fields. And again, my question is, okay, what is the field? What is the thing that's moving? Because we talk about these things in the form of what the mathematical equations tell us. The mathematical equations are based on charge, and they have an inbuilt attraction and repulsion, and therefore then what we end up doing is making ourselves into artificial questions. So let's say that in the models that do not require charge, you don't have a charge on an electron. So it's not moving through a field with a charge. It's moving, if it's a particle moving through another particle, a flowing particle field, for instance, then you have a totally different question. So I think that's one of the things because, again, I myself have been working on a model that, charge, it's all Newtonian, there's no such thing as charge. I think that's one of the things I have a question for the people working in those systems. As Michael was talking about assumptions, one of the people who died in the last couple of years, boy, I can't remember. I'm so terrible with names, but he always on our group said, "What are your assumptions? What do you assume?" And I think again, the idea of a charged particle moving and then causing magnetic fields. My question is, first of all, do you know give me your definition, a physical definition of what a magnetic field is. Give me your physical definition of what that particle is. And I'm still, even if you have that, I have to say, okay, you've got this magical thing called charge. It's hard for me as a person to say, just because you put a minus sign on an electron, that it's going to then be affected in this way by something magical called charge, which emanates, for instance, perhaps infinitely out. For me, I have a hard time with that, but I don't know what those answers are on the other side because I can't imagine it. That's why it's hard for me to say, here's a moving charge and it's in a field. Is that causing a magnetic field? There was a video that just came out on a YouTube channel by Jean Ruba. I can't remember. He's one of the CMPS member. Well, he's associated with the CMPS. He's in France, and he talks about an electron moving does not cause a magnetic field. And again, my question is, okay, tell me what those are, and then I can believe you or not. I mean, the statements are statements, but do you have something to back it up? So, again, I've got, let's see, I got Bob Gray here, Alistair, you're here. Oh, Dennis, there's somebody waving. Hey, Dennis, how are you?
Good, thank you.
Okay.
I just wanted to make the point that a man by the name of Morton Spears, S-P-E-A-R-S, wrote a paper in the Galilean Electrodynamics. Actually, it was he died before he could finish up. It was his daughter, who was an economics professor in some big Midwestern university. She had it published posthumously. And I finished it up, saw this paper, I liked it, I finished it up, and it's all written up in a book, Foundations of Neo-Spearsian Gravitational Theory with Application to Earthquake Early Warning Systems. And it's inexpensively priced on Amazon, and it's free on ResearchGate and academia.edu, and also on LinkedIn.
Okay.
So that ties together charge and gravity. For him, gravity is just an electrostatic phenomenon. It doesn't involve magnetic fields.
But does he talk about what fields are, what charge is? Because, I mean, I think one of the things I hear a lot is people eliminate gravity because, for instance, they take a fundamentally light-oriented model like ether, then they try to fit gravity into it. Or they're going to say that here's, gravity is really part of the electrical system, but they never tell you what the field is. They never tell you what the charge is, why those attract. Is there any of those kinds of answers in this work, or?
In this work, charge is an undefined term like point, line, and plane in Euclidean geometry, and it's subject to certain axioms or postulates, depending on whatever you want to call it, such as Coulomb's law. Coulomb's law is an axiom, unproved, which tells how charges act on each other, how charge acts on other charge. And then, of course, there's, you can, if you're into, for example, J.P. Wesley's Electrodynamics, which he put out in his 2002 book,
right, yes.
Scientific Physics, they go on and discuss other results, such as magnetic fields being generated by charge, which again is an undefined term. And it's like a point, line, and plane in Euclidean geometry. You just have to either you have to intuit what they mean by it. Every logical theory has to start out with undefined terms, at least one.
Sure, that's
Then
the
there has
assumption,
to be
right?
axioms about them, which are not proved.
Right.
Now, of course, if someone, for example, Harold Milnes wrote a paper on Coulomb's law, which he did an experiment, which he said counterindicated it. If that's right, then the using charge as an undefined term and Coulomb's law as an axiom about it would be a mistake. So it's not independent of empirical verification at all. But a lot of people don't understand that to have a theory of physics, you have to start, from a logical point of view, you have to start out with undefined terms. This
Sure,
is in
absolutely.
geometry, point, line, and plane. And then you have to have axioms and postulates about these terms that then have to be experimentally verified at some point. But the thing about, and then of course you have your theorems that you conclude from your undefined terms and your axioms and postulates involving those undefined terms. And that's your theory. But the thing about Spears's theory is that it gives an idea of how an earthquake early warning system might be devised that, better than the one in Japan, for example, where they just noticed that electronic signals travel faster than seismic waves. So if there's an earthquake 50 miles from Tokyo, if they get their word out immediately, automatically, they have a little time to pull off the road if they're on the road going 60, say, before the quake hits. So there's a certain, but this would give much more warning because it's often been remarked by seismologists and like-minded scientists that it just so happens that oftentimes there's lightning out of a clear blue sky just before an earthquake. There's a very strong electrostatic phenomenon associated with earthquakes. And so his electrostatic theory of gravity fits right in with the idea of earthquake early warning.
Yes. Now I'm gonna sort of jump in here. Now, are you saying that a couple of things I know you're saying? In fact, Jim Marison, who's a longtime member of this group, mentioned that it was Neil Munch that I was talking about. Thank you very much, Jim. That's totally right. Neil Munch was a person in our group, the MPA at the time, who was talking about assumptions. What are the assumptions you have? And the idea of the assumptions, like you were saying with your what you start out with, these assumptions are things that you cannot prove. You're not going to prove. Are you saying, I guess, in the context of this, do you think that the work you're talking about would make the assumption that charge just exists, and that's the assumption that they start from?
It's an undefined charge. Is an undefined term, which means that it's something that you're going to talk about with your axioms, and then derive from those axioms theorems about it, which then may well be experimentally verifiable or unverifiable. They may turn out to be wrong. As I mentioned, Harold Milnes has this paper on Coulomb's law where he did this incredibly dangerous experiment and just decided that it wasn't actually correct. So it's not something that's just assumed. It gives you something to verify or to falsify.
Yeah, but I think what I'm not understanding one part of what you're saying there, but I think
What's
what
that?
it is. Well, no, I'm not criticizing. I'm just saying. I'm trying to say.
I'm just
the charge is an assumption, but are you saying that later on with those assumptions, charge can be then verified?
Well, the assumptions about charge can be verified because you can do an experiment where you say you have an electrostatic generator, and you have these tremendously high voltages, and in a case like that, you would expect that if the assumptions about charge were going to be falsified, that would be rare because it would be such a far out case, huge amounts of charge and so on. It wouldn't. If there was
Right,
some,
but still, I mean, I understand, but what that means is that the model that is based on charge is making predictions, but to
Yeah.
then go one step further and say, okay, because how do you say, showed that those predictions in fact did come the way the model predicted, that therefore somehow verifies the concept of charge. Well, I think that's not. I don't think you can make that leap. But what you can say is the model that based on charge is making a correct prediction. But to
Yeah.
actually then go say that no, charge is real because I'm using it, and therefore.
no, I didn't say that. You misunderstood.
Right,
me.
right. No. I wasn't saying you were. I was trying to
Yeah,
clarify it. No. Absolutely not. Okay, I got you. Okay.
So the theory allows you to make certain predictions, which you can then verify or not. And
Sure.
the thing about it is that the central thing that drives Spears's theory is that the proton is much more massive than the electron, over 1,800 times more massive. And that, as far as I know, was never used by anyone else to do anything.
Sure. Okay, all right, but I appreciate that. I'm gonna move on here, and I do appreciate your very interesting comments on charge. Of course, the guy who's normally in charge here, Franklin Hughes, on a plane. He's really going on vacation, but he must be already homesick for not seeing us. And of course, I chose this just to make him pay attention because he and I have argued about charge for a while. But he says charge is too complex a phenomenon to be an assumption. Now, that's a loaded question. Number one, first of all, we have to describe what an assumption would be. An assumption, talking philosophically, like Michael talked about, and anybody else, we're talking about that is something in our current little area of the universe. We are assuming this. We're not going to try to explain it metaphysically, or physically. We're just going to say that exists. Now, you're saying that assumption, which again is something you don't want to prove or disprove, you're just saying is you're saying that charge is too complex to be an assumption. Now, the only way I can interpret this English is to say that an assumption is something that you can explain. So charge is too complex, meaning you can explain it. I'm not sure, Franklin, I'm getting the gist of it. So I would say, first of all, to say it's complex, if you have a model where charge doesn't exist, then it isn't complex because it doesn't exist. So if it doesn't exist, there's no complexity. But if you do have a model with charge, then you have to say what that actually is. Then if you say what it actually is as subcomponents, that charge is actually happening because of these things, then you can say charge is a way that we can, a meta description of something else, but the reality is this is happening, so therefore you have to say charge, like energy, is a concept. So that's what I would say myself as to that kind of statement. So if charge is too again, if it's more complicated, meaning it can be described, again, if you have charge, it says that, for instance, the electron is kept in orbit around a proton because of the charge difference of positive and negative. But then you have a model like the particle model my father and I have, which says, okay, it's orbiting because of these physical reasons. There's no charge. Then the question becomes, is charge real? No, it's like energy. Energy is a great concept. It's very useful, but it's not necessarily a real thing. So, well, anyways, thanks, Franklin. Of course, I do want to thank Franklin, who is here all the time doing that charge. Okay, here he goes. He's discussed. Franklin can't get away from the Saturday morning chats, which he is the actual host. I am not. I'm just a visiting host today. Charge needs to emerge as the result of something like ordinary material. No. Okay, if I were next to you in the plane, I would bop you on the head, Franklin, because now you seem to be saying the exact same thing that my father and I and other people are saying, that charge actually does need. We agree on, if today has any merit at all, that Franklin and I actually agree on the statement for charge, and that it has to that is really nice. I like that. I will have to steal it, and we'll put it in our book, and we'll take credit for it, and we won't tell anyone that you said it. But no, charge needs to emerge as a result of something like ordinary Newtonian physics. Yep, absolutely, I agree. In our particular model, for instance, that's absolutely true. Everything's a Newtonian mechanics. So. Alrighty, let's see. Anybody else we have in our room? We have J3, Bob Gray. We talked with Scully. Bill Lucas. He's got a hand up. I'm not sure if he is. Oh, is he there? Yeah, he's live. All right, we're going to put up Bill Lucas. Bill is let me bring him up. Bill is a lifetime recipient award of the CMPS Lifetime Recipient Award. He's a great scientist, in my opinion, of course, in the opinion of our directors of our organization. And he has of his force models, and if you haven't gotten his books, they're really interesting. A lot of heavy on math, but there's a lot of good philosophy. But I'm going to let you talk about, I'm very sure that you would have an opinion about this. I'm going to yield the floor for you to talk about what you would like here on charge. Well, welcome, Bill. How are you doing?
Thank you. I want to say that under Newton and classical mechanics and science, the idea was you perform, excuse me, you performed experiments, and then you try to write down in equation form the results of your experiment. And the more that you can explain with your equation, the better it is. So it turns out that when you're writing Coulomb's law and the other laws of electrodynamics, that there are some constants that need to be put in order to put an equal sign to represent what you measured. And when you do that, we put in a constant. We put a constant in for charge. We put a constant in for mass. We have a number of constants, and if you ask the people who did the experiments, what is charge, what is mass, they usually say, well, we really don't know, but we are putting our ignorance all in this constant. And we might know more in the future,
right?
But until we have more experiments that can show something that our current experiments can't show, we will go with this idea of a constant.
Gotcha.
And so that is very interesting. Well, on this question of charge, there were some experiments that were done by Arthur Compton and his last graduate student, Winston Bostick, and they manipulated the electromagnetic field in a plasma, and they were able to make what we call a standing wave state, and that was made entirely of the field. No charge. They didn't put any charge in. But if you measure the field coming out of this structure and you want to describe it mathematically, it's a toroidal ring that they make called a soliton. If you want to describe it mathematically, it's easiest to do it using charge, the concept of charge. Mm-hmm. But they know there's no charge there, because they started with no charge, and all they did was
Right.
manipulate the field. So then the question is, well, uh, how to resolve this issue? Do we say that the field is the fundamental thing and the charge is just an approximation for now letting us write mathematically the structure of the field as a function of distance? And what they found was the charge does not seem to be the source of the field. The field seems to exist separate, and when it has certain structure in the field, we call it a charge. And so that's the kind of issues we have to deal with. And so then the question arises, well, how do you make progress? How do you improve things over time? And you can perform more experiments. You can try to find new phenomena and that sort of thing. And the approach that I have taken in my own work is I'm trying to explain everything in terms of electrodynamics, in other words, gravity and that type of thing. And so when I do that, I cannot completely define charge.
Sure.
And so I leave it kind of an open question, but
well, I think that's really, actually, I have a response to that. First of all, I think that was one of the best explanations I have ever heard of people working the way you work, which is in the traditional way. Because I think your work in the traditional way is the best there has been. That is, the person who's pushed that further has been yourself. But for your explanation of how these things are very useful, we talk about them this way, but it doesn't ever tell us what it is. I think that is extremely profound, what you just said. I've never heard really, you may have said it before, but I got it now. And I think that is amazing. The second thing is, the answer I would give to you, and this is one of the things that when I saw the Untitled new experiments, and I kept, for the last 20 years, I've been asking this one question: what is the field? And what is a field? And I think the answer, Bill, in my opinion, and one of the reasons our particle model seems to go pretty far, and again, I'm not saying it's right or wrong, it just seems it's going further than we ever would imagine, but it's good. But the reason is, I think, is because we give the physicality to a field. And once we understand what those things are, and and it's all Newtonian, that maybe the answers will come from that. And what the system that you have in your force equations, and the predictability, which I am astounded in how you and your son have come up with the predictions, especially with the periodic table and with atoms, those kinds of structures, way better than today's modern science. I think it's quite that in itself gives us a precise answer as to where where the corrections have to be made, where the scientific data is showing that there are problems and that our current system isn't working. Your system works way better, which I've read the papers. I am in total agreement that your system is. But I really do think the answer comes from us finally saying, what is the physicality of gravity? What is the physicality of a field? And I think that's where it's going to happen. Now, what I would say is that any model, it doesn't matter. Our model, Glenn Burkett's model, Jeff Yee's model, whatever model it is, it doesn't matter. It's going to have to be able to have your calculations match up in some way. And that is, yes, you don't have the physicality of those things, but how they work in the relationships are there. And if you have a model that doesn't explain that, you're in deep doo-doo, as they say. But no, I think that's what it is. I think what the answer is, you're right. I think we're at a dead end, not because, I think you've hit it. You've come to the part where, okay, Bill Lucas, in the history of science has taken the charge electrodynamics to its furthest point, and now to get beyond that leap, we now can't be necessarily content. And I'm not saying you are at all, because obviously you're a great mind in science. I know that. I know one of the things is you're saying, okay, where is that next step? And I think that next step, Bill, really is in that critical. What is that field in Newtonian terms?
Yeah. Also, in the work that I have done, I've said that charge, the vibration of charge, is the source of the gravitational field,
right,
and force of gravity. And so I've been able to predict the value of big G, which
Sure.
no other theory that I know of can do.
No, there are
from
some
the vibration,
yeah,
and
there's
also
some.
the cosmic background radiation from hydrogen and helium, which make up over 70% of the universe. That is predictable directly from electrodynamics and the vibration of the dipoles and quadrupoles in the hydrogen helium atom.
Yeah, no, I think from that it stands, but there are others. I mean, my father wrote a paper on how G is not constant, and like you said, I think one of the other things that you said was talking about, especially like with the charge, Coulomb's law. I mean, gravitational G. These are. You said it very elegantly. You said that those constants are our ignorance wrapped up into a number, right? I mean, that's basically what it is. I mean, that was amazing statement. That was amazing statement. And so what I would say to you too is that, again, because we're dealing with gravity and electric fields without the actual, is it a Lesage type model? Is it, whatever model it would be, we still are not going to be able to get past that until we, make that one leap. So anyways, I think that is amazing. You've already blown my mind 3 times in a very short amount of time.
I have one piece of work I just am writing and getting ready to publish this week, and that is been able, I've derived the force of gravity from electrodynamics, and
Right.
now I've tried to write down the orbital laws for the quantization of gravitational orbits. We used to have what was called Bode's law,
Sure.
which
sure,
worked
sure.
sort of for our
Sure.
solar system, but then we found a few
Outliers.
planets and moons that it didn't work for.
Right, outliers.
And so
yeah.
we knew it wasn't perfect. But anyway, I've been able to derive a new version of the quantization of gravity, and it works for all of the items in our solar system. And we have also discovered what we call exoplanets.
Sure.
And these are the planets of other stars in our galaxy, the Milky Way galaxy. And we now have over 5,000 of these exoplanets that we have measured their orbits. And
Right.
The 450 best measurements we have, most accurate, I have analyzed and shown that electrodynamics is able to predict the quantum laws
Mhm.
that seem to work within the accuracy of our measurement for the first 450 of those, that are 500 that
Right.
we've
right.
measured. And it was surprising that we could do that, but we haven't looked at the other 4,500. And
Sure,
there may
sure.
be some more that don't agree with that, So, but it's unusual. We have, instead of having 9 planets, we have 450 planets that we get from this analysis of the exoplanets. And so anyway, I'm about to publish that and to show that the accuracy is better than 2%.
Well, that's super. Yeah.
The error, uncertainty is less than 2%. So
No,
that's,
by absolute all means, if the mainstream is using what they are doing now, your equations are much better to a nth degree. And why that doesn't happen, of course, I think it was Michael who was saying that the progress of science. There are a couple of things he said. We're not dissident. We're not dissident science. we're scientists, and this is the way it always works. And I think it was Michael earlier on today who said that we're 100. It's always 100 years behind mainstream, right? So, but congratulations on that. That's super. Thank you so much. And like I said, I'm a great admirer of your work. So are we at the CMPS. So we're looking forward to that paper, and make sure you hopefully publish it. We're going to be on the East Coast. I'm not sure where this year, but regardless, we'll be looking forward to that. Thank you so much, Dr. Lucas. Greatly appreciated. All right, very great. Dr. Lucas, again, the predictive power of his work, again, based on electrodynamics is quite good. Now, again, I think it's a great mind and a great critical thinker, and that's why he blew my mind, is a person who has worked decades and decades, really brilliant mind in physics and mathematics, like Dr. Lucas. He understands the limits of what he's doing, even though the predictive power is so much better than mainstream. And I mean, it's sad that our universities don't do what we're doing here, because this is where science is happening, that, they don't look at this work and say, hey, yeah, we should use this. This is way better. But then the author himself says, look, we are sort of somewhat stuck. Where can we stick this? And again, in my own opinion, because I've been around people like Bill Lucas for over 20 years, some of the greatest critical thinking minds, in my opinion, in this group, especially this group, I've been privileged to know lots of them. Unfortunately, lots of them have passed on. I know Bill Lucas has known a lot of these great minds who are no longer with us. One of the things I have learned from them is always to be critical and always find those areas where, even in your own work, it's not working, or I'm making this assumption of charge and fields. I know very much so that's what I'm doing. And what Bill is saying at his work is, even with those assumptions, the mainstream science doesn't know how to deal with them to the right degree, or look at the data. And not only that, their predictive powers aren't very good. Here are the things I'm introducing to make them even more accurate and even better, make a better model. But still, here are the limitations. That's super profound. But it's quite amazing, the work here. Again, we are, let's see, 11:36. We go until noon time Eastern time, and today's subject is about charge, and I think moving particles in fields, that kind of thing. I think this has been talked about quite a lot here in this group. And again, there are models without it. My father and I are working on a book on that. So our goal is to get that out. I'm working on graphics, believe it or not, because our particle model has graphics that really don't exist, and I have to draw them nicely and draw lots of particles flowing together and flowing in different directions and that kind of thing. And so we've got all the basis for it, but we're now putting it into a form which we think is going to be the best to get that information across. So that'll be interesting, because that's going to throw out a model for everything in a Newtonian sense. The entire universe is Newtonian, infinitely up and infinitely down, and we have principles that can do that. So that's cool. This is a really good question, and I definitely want to. Actually, I'd like to interview somebody from my dissidents, have them interview some people from the Sapphire Project. Those of who are not familiar with the Sapphire Project, it is an extremely interesting project, in my opinion, cutting edge in a lot of ways, that's being done outside the mainstream, being funded by people outside the mainstream. It's through the Thunderbolts Project. If you go to thunderbolts.info, you can find out about that. And the Sapphire Project, I think, actually has its own website. And what's interesting, even though that the premise of the experiment, this happens often. My father and I tried to do an experiment in the movie Einstein Wrong, The Miracle Year. Go to einsteinwrong.com. You can watch the movie online. A documentary shot over 8 years. it's often the case that you do an experiment with intentions of X and you end up with Y, and you would have never gotten there if you didn't take a chance on that first X. And we and my father and I started out making an experiment trying to show that gravity was in fact a particle. And we ended up not being able to show that necessarily, but we ended up working on something that eventually came to a totally new kind of model of the universe, especially when it came to light. It was a non-ether Newtonian model. And that was interesting because it was basically, here's the experiment, here's what we tried to prove, but we got something very different from it. And I think that's what's happening with the Sapphire Project. And please, I may not get this right, so please go to the website, but I'm going to try to say a little bit about what I know. But basically, when they have this ball and they're charging this ball and trying to basically create the sun in the laboratory, and not like fusion, but trying to use, look at plasma. They're finding that when they do this, they're getting very heavy elements that are being created on the surface of this thing. And of course, that has major implications. One of the things is where do the big heavy elements come in the universe? The idea is they come inside the sun. But they're getting this on the surface, and this is not something that they can say. Now, that is what I think is happening today, and that's what's been a lot of the recent excitement. In my opinion, is this great? Absolutely. I am a fan of the electric universe, not because I, again, subscribe to everything that they say, but I do subscribe to them creating critical thinking and a large community of critical thinkers. And they have the absolute right to go out there and try to make everything in the universe electric. Our minds are free to do what they want. And that a lot of people sort of think more maybe electrically than they do mechanically. And my father and I are more mechanically inclined, so our model is all mechanical. But regardless, their idea of the Sapphire Project was to go out and make an experiment, and something in the idea of this, I believe it's a sphere in a chamber, a vacuum chamber, and then they put an immense amount of electrical current onto that. And so I think the idea, well, I'm pretty sure the idea was to try to verify, just like anybody else who has a model, an electric universe model, that the universe is more electric than gravitational. That's their idea, that this experiment would help show some of that. But instead, they had some residual, occurrences that have made their eyebrows go up, and the world should be looking at that, but I'm not exactly sure the world has been looking at it, but certainly in the dissident area and amongst themselves. So I absolutely, on the Dissident Science Channel, which is my own science channel, would love to really interview somebody and talk with them about that. So please, anybody, I'm sure I can get in contact. Well, I'm getting almost 3,000 subscribers. Of course, Electric Universe, when I started my channel, just passed from, well, they've been on there for 12 years now. I've only been on for coming up to 3 years. I only got like 3,000 subscribers, but they have like 150,000 now, maybe even more subscribers. So they've got quite an amount of people who look at their videos, who see their stuff, way, way more than me. And but again, I applaud them greatly because they have evolved. They also 15 years ago or 10 years ago laughed at our organization saying, Einstein's wrong, you're kidding, that's all they care about. Now you hear Walt Thornhill, one of their spokespeople, talking about that quite a lot. In fact, they've had quite a lot of people, and they have come around to that idea that in fact Einstein's special and general theory of relativities have great problems. In fact, Bill Lucas knows that more than anybody, having been kicked out of one of the top scientists in the country because he had the audacity to challenge relativity. So that's what I know about the Sapphire Project, the idea of this plasma ball and then creating quite heavy elements from that. Is that being created from nothing, or how is that happening? Or is that a transformation? That's a huge thing. And of course, the idea of us being able to manufacture anything from basically the parts of atoms and make atoms themselves is something that's extremely technically interesting to the human race if we want to build huge structures. So I think that's, at least that's what I know. So see, we got some people, EU, Electric Universe, that's their abbreviation. So absolutely, there's a lot of people, like I said, that's their sort of bent on the way they see the universe. Our model actually gives you a very it's a precise definition of what is gravitational, what's electrical, what's inertial, what's gravity, all those kinds of things. That's what our model talks about. So, but Electric Universe does some really great work, and I do believe that they have not proposed anything for their field or what charge is. Obviously, in Electric Universe, charge is very important. Again, I think, in my opinion, we're going to come around to the same thing that people in the CNPS, the Chappelle Natural Philosophy Society, has come around to, and that is charge as a concept. They're all, let's face it, they're all concepts. But we eventually have to, in our unicosm and our, not the macrocosm, not the microcosm, unicosm meaning the world and around us, not infinitely up or down, we do eventually have to make some assumptions if we are to do models. I know philosophically, the way my dad says it, I don't know if he said it or something like this. We're lucky to cobble together any equations or models to do any types of predictions. It's never right. It's just less. I put this part in. It's never right. It's just less wrong. All right. Some other people who would like to, and anybody would like any questions that you may have. We are 15 minutes before the end of this. I don't have necessarily anything planned. I didn't have a slideshow or anything. I didn't have time to put that together in the short time I had while Franklin's on his vacation. But one of the things is just to let you know, if you haven't checked it out, I wonder if I can show you. We do have a Wikipedia, and one of the things is it's a natural philosophy wiki, and I'll do a little bit of advertising out here for that. And the wiki was busted, but I'm going to show it to you here. Let me see if I can get this and do this correctly. I am, for those of you who don't know, I'm a software engineer, work with supercomputers and human language. That's what I do. But I will say that we do. Let's see if I can share. Sharing screen is easy as with two monitors. Yes, it is. Share screen. Now, I want to share not my screen only. So I wonder if I can do that. Oh, I see. There we go. Application window. Yes, I knew you could do that. All right, so I'm going to share this. This is our Wikipedia. You can get to it at wiki.naturalphilosophy.org. It does, in fact, contain most everything in the database at one time. A couple of years ago, I translated our database into Wiki format. And this is, again, as what we would call a natural philosophy wiki. And the idea here is for us to be able to write things that challenge things. In fact, if you see this right here, there's called a Wikipedia Dispute. This is actually an expansion that you can put, and if you go to something like the Big Bang, which I'll click on here, you can see at the very top, it says Wikipedia Dispute, Wikipedia Big Bang, and it says here the Natural Philosophy Wiki page disputes contents found on the Big Bang. Now, I put this in, and it's totally, it's a long time. The edit history on this, let's see, view the history. Last time I touched this was back in 2017 and 2016, but what we would like to do is to be able to create these pages that will be able to open to much more criticisms of things like the Big Bang. And it's interesting because this dispute thing is, I wrote some computer code. All you have to do is put in this Wikipedia dispute and then the Big Bang, and our Wiki will automatically expand that to what you see here. You don't have to write any of this. And that just means that the page that you are working on actually is in dispute with the Wikipedia because they will not allow alternative ideas at all. So this was busted everywhere. If you're interested in working with us, we do have and say that this is a closed system. The reason it's closed because when you have an open Wikipedia, as Wikipedia is, they have their, I call it the science Nazis or their editing Nazis out there. And so when you do something as simple on Wikipedia as add the name of Dr. James Maxlow to their expansion tectonics plate, I bet I can actually go to that. Wikipedia. I'll go to that and I will search on expansion tectonics, expanding, I think it's expanding Earth maybe. And down here they have proponents of it, or they would have proponents of it listed. I believe in the history you will see a place where, let's see if I can search for that, the Hilster. Maybe it's on a page, let's see, older 50. The Hilster, nope, it's even older than that. But I did in there at some time put a list, James Maxlow. There we go. In June of 2017, I added, let's see, I added, where is it? Where are you? Come on. Oh, it's glitching on me. Sorry. Sorry, folks, it glitched on me. I went to do something to get a break. So what happens is sometimes this is a stream. Oh, wait a minute. This StreamYard does glitch. So I was showing a Wikipedia page, and it glitched, completely froze on me, my computer. So anyways, you can see that back in 2017, I tried to add to our to the real wiki on their expanding Earth page, James Maxlow, who is the guy today. There's no dispute that he is, in my opinion, opinion of many, he is, after Samuel Warren Carey, who even the plate tectonicists look as to being the father of expanding Earth and then expanding universe, or expansion tectonics, which is the one that James led, that they took it out. Now, why would they do that? Why would somebody? And I think maybe they look at my channel where who I'm associated with, and decide they're not going to allow that to be included. So because of that, we do have our wiki. I'll put it in here. Let's see, I can make a banner. I don't know if we have our wiki listed here, but I will put it up here. So if you are interested in actually contributing it to it, and you are allowed in this Wikipedia to put your work, you're allowed in this Wikipedia to put your profile. You can put edit. You can help edit it in any way. You can add parts of it that you think that should be there. It is closed, and the reason is because I know I've argued with Franklin about that. in my opinion and other people's opinion that I've talked with in our directorate, that we feel it's best the reason closed, because if we allow everybody is opened up, we're just going to have people come in and just trash it. And the idea here is for us people to respect that says, okay, we're trying to put scientific things in here, and the idea of consensus will never allow for alternative ideas. And that's one of the things we don't want to have. So anybody's work, in fact, if you go there, you can look at some of the work. I fixed all the bugs, I believe. It's really based on the Media Wiki. A Media Wiki is the open source. The software that runs Wikipedia is called Media Wiki. Media Wiki is an open source, meaning its computer program that they use for Wikipedia is open to everyone. That is, anybody can use it. So I actually took it. I got the Wikipedia, I put it on our site. I actually made info boxes for things, those little info boxes you see on web pages. I even made things for theories, also for papers. I also included an extension for latex mathematical equations. I'm not going to show you those because I think StreamYard seems to glitch. My computer's a pretty good computer, so it's not really the computer, but if you take a look at it, you can actually see that there are equations there that look really beautiful. If you publish in our proceedings, we have a conversion program where I can run it and I can change your proceedings with graphics and everything and figures, references all into Wikipedia. The great thing is that will be searched by Google. So those pages are searched. In fact, if you do some searches on certain things, the only place you can find them is in our Wikipedia, and then you'll actually see it reference those. So we're looking for people always to help out with that. If you're interested, if you want to put your profile and all your work, and that's all you want to do, great. We can get a login. If you go there and you say contact, there's a contact on the right. I changed that to be a little more clear. Then you can actually then go in and put it in yourself, do your own editing, fill in your bio the way you want it to be. My dad and I have a starting page for the particle model, which is horrific. It's not good about it. I need to really get rid of most of that, and once we get a particle model, we'll have that out there. But if you have a model, you can put all that information there. So we're looking for that Wikipedia to be able to put, for instance, alternative arguments against the Big Bang, and here they are. Here's the papers, and the idea is we would like to get funding, and we don't have any of this right now. We have some donors to our organization, but we don't have any serious funding. But one of the things what we want to do in serious funding is to put the information out of all these works. We had talked with one gentleman today, Michael, who has been publishing with, I guess his name is Nick somebody or Nicholas. I'm getting terrible with names. He had me type it in. I can go back and look at it. But regardless, those kinds of works we can put, if people allow, we can have those in this Wikipedia and put a knowledge of science the way Wikipedia really should be, and that it should be open to new ideas of new alternatives in science. So as for the expanding Earth, Neil Adams did some great good animation about expanding Earth. Absolutely true. That's how I got into it. It was in 2005, I think he put out his first video. He has some money. He is not a poor man, probably a wealthy man. He's a cartoonist who's most known for his cartoons for Batman. In fact, if you subscribe to his channel, lately he's been doing some drawing live of his Batman, but he also has a prime matter particle, I believe is what he says, that is made. And so you may want to take a look at it. But that was the thing that got me, because when I saw his video, I go, you're kidding. This just makes so much sense. And from that day on, I got to meet great people, and I got to even bring via our conference to meet James Maxlow, who wrote, in my opinion, the most important book in geology ever written, which is his latest book. So look up James Maxlow, and I guarantee if there's anything I will say about the science from this group, and his is amazing. So let's see. Here's something about our subject here. We have Nick van Biedentung. I don't know if that is German. It sounds German. Nick Knight. Yeah, or no, I don't get me on German. I don't know. Yes, it is gravity. We're talking about, let's see, Cornelius. I think we something before, but mass is a result of patterns of waves in a medium. That is a model. That's some people's opinions for sure. Not something inherent in an object. The object itself is a pattern of tension waves within the medium. And I guess the idea is that those kinds of models, again, I will say, and this is also my opinion, that ether models were specifically made to describe light. They were not gravitational. And I think people are now trying to make ether models into everything, and that's fine. That's absolute right people have, but I think that's where it comes from, that this is like Jeff Yee. So if you haven't seen Jeff Yee, I think that's very a person who's really into that direction. Not something inherent to an object. The object itself is a pattern, tension, waves, and medium. And I think this was a response to it. Yes, it is gravity. Can't gravity be a ground state of charge? If not, why? Again, that's again, that shows you how so many people see charge as fundamental. I do agree. Actually, I can say that with that it is a concept right now which we need to have explanations for. So I just think, again, we have to be, I think we get so bogged down in the terms like monopoles, etc., dipoles. I think we have to go back to what lots of us are saying, including Bill Lucas, and that is, yeah, we're using these terms, but what's really behind it? I think that is a question that's going to get us further along to move beyond where we are, because I think we're sort of talking about this around and around and around and around. We have to silently say, okay, time out. Now we got to concentrate. What is a magnetic field in Newtonian terms? And that's what some of the models out there are trying to do. So again, if we are at noon, I want to thank everybody who's been participating in these Saturday morning chats. I want to thank all my subscribers from my channel. I see we have a pretty good mix of over 20 pretty much during most of the time. I want to thank my subscribers from dissidentscience.com. These are the two YouTube channels that we're broadcasting live today. You go to youtube.naturalvelocity.org, and that will literally take you to our YouTube channel, which is almost 600 people subscribed. If you are a Dissident Science YouTube subscriber, I want to thank you for being here today. I am taking guest hosting for Franklin Hugh, who normally does this. I am coming out with some new videos shortly. As you can see in my background, I ain't at home, so it's not easy to make really well-crafted videos when you don't have a really good studio to work in. But I would recommend all my subscribers to subscribing to the YouTube channel for Natural Philosophy. There's always interesting things. If it floats your boat, great. If not, but at least be there, so that I will be here next week. So I do want to let you know, both in the CNPS and the Dissident Science channels, I will be here filling in for Franklin. It won't be broadcasting after those two, won't be broadcasting live to Dissident Science. The only reason I'm doing that here is because I am the guest today, and I just wanted to do some cross-fertilization for both people in the CNPS know about my channel and vice versa. And we do, again, have these websites, so if you want to check it out, if you are totally new to what we call dissident science, but which we are really scientists. I would say we are the cutting edge scientists. This is where you find the Copernicuses and all those kind of people like Bill Lucas, Glenn Borchard, James Maxwell, all those kinds of people, Maxwell, all these kinds of people who are the great scientists of our time. You can read about all of those at sciencewoke.org and find out about them, what their work is all about, why, believe it or not, mainstream science is pretty darn lost, to put it nicely. So thank you, all of you, for keeping these Saturday morning chats going. We started in 2008. We are stronger than ever. The platform is StreamYard. We averaged today almost 20 people from these two channels. So thank you so much. I will be back next week. I will be announcing the a topic, which I think will be interesting for everybody. And also, if you are interested in presenting your work, you can, you will have 1 hour, 60 minutes to present with slides. You do need to have headphones and a microphone and a webcam to be able to do that. We prefer to see the people. Not super necessary, but it is necessary that you have the slides as well. We don't want to really just have people talking. Slides are more organized. And you will be able to present your ideas if we find them that of course, we do look at it before we just have somebody present. And if you want to present your model, your idea, if your latest work, I would recommend that. And also, I would also recommend checking out the other channels. If you go to naturalphilosophy.org, on the right-hand side, you will see the channels that we endorse. I think there's even more we need to put there. And check those out. And that's a great source of people talking about cutting-edge science. So thank you so much. I want to thank Steve Scully, Bill Lucas, Dennis Allen Jr., James Keene, XP-Tech Michael as well, and other people have been in and out. We have Cornelius. I know you're there too. They're all in our waiting room, and hope to see you next week at noon. I guess it will be February, will it be? No, January, no. 7, no. It's still 25 plus, no. It would be the 32nd of January. No, it should be February 1st. So I believe it'll be February 1st. But next Saturday, I will be here. Again, thank you, Franklin, for doing what you do. Super greatly appreciated. And everyone, take care. And like I said, don't believe anything any of us say here. Check it out for yourself. Read up on it. Make up your own minds, because that's what's most important. And there is no one answer. And we all need, very important for all of you with your own theory even, let's support each other, because if we can't support each other, who is? We don't have to agree on everything, but we do have to agree that I have much more respect for a person who has their own theory, even if it's far out, than I do a person who just believes mainstream science, takes that, and then laughs at people who have different ideas. Don't go for that. I'd much rather hang out with people with crazy but interesting ideas who are trying to make science go forward. Thank you all, everybody. I'm David D. Hilster. I hope you enjoyed this session, and we'll see you next week.